Hi, in this video I'll explain how Origami speeds things up by caching or remembering the results of calculations in memory. This is designed so that you don't have to think about performance much if you don't want to, but understanding caching can help you understand how Origami works and can help you make more efficient sites. So I've got a simple little project here, a very trivial blog based on the Origami blog start project, and I've got a site definition here that we'll look at, and this site definition processes some markdown. I've just got a couple of tiny posts here to create a little blog site, and we'll use this to look at how Origami handles caching. So in a site definition like this in Origami, the language is a dialect of JavaScript, so you're creating here an object using these curly braces, and then you've got a set of definitions inside of it for the pages and other resources that will make up your site. And I think it can be helpful to think about a site definition like this in Origami as working something like a spreadsheet. So in a spreadsheet, you've got cells with formulas that can reference hard numbers or can reference the results in other cells. And in Origami, in a similar way, you've got definitions for essentially a virtual file here that's based on the content in a real file, like this about.md file or this page.ori template. And this formula is going to be invoked by Origami to calculate about.html. And like a spreadsheet, it's going to be tracking the dependencies so that it will calculate this stuff once, and then if nothing is changing, when you ask for a resource like about.html, it'll return the result immediately. It will only have to do work again if some of the underlying data changes, if you, for example, change a file. So in this particular example file, the property definitions, most of them use an equal sign. That's Origami syntax. For what in JavaScript would be, in plain JavaScript would be a property getter. Now for comparison, if we look at a simple Origami file that calls a standard JavaScript function, here we've got another object in curly braces. This one uses the standard JavaScript colon to define each of the properties. And like in JavaScript, Origami interprets this colon to mean that this expression on the right side should be evaluated immediately when this object is being constructed. So all of these properties will, in this case, these little strings, will be established when you instantiate this object. And that's important because this JSON.stringify, that's a standard JavaScript function, part of the platform, and it expects that you're going to give it a plain object with simple properties. So for interop, Origami supports the same colon syntax. But for things like defining a site, Origami, the preference is to use these equal signs. They have two effects. For one thing, they define a property getter. Getter, if you've worked with them in JavaScript, is something that from the outside looks like a property, but on the inside is a function. It's only going to do work when you ask for it. The second thing that these equal signs do in Origami is that it will involve Origami's caching system. So when you ask for a resource like about.html here, it will do the work to calculate that. It'll evaluate this formula, and then it will hold on to that result and keep that in memory so that if you ask for it again, it'll be immediately returned. So that's the other effect of using this equal sign. So just to see how that works in practice, I'm going to start a little server here. And I've got some logging going on so we can keep track of what it's doing. We'll go to the About page. And so here's this tiny little about page. And if we look at the server logs for a second, Origami's server by default includes a tiny bit of logging. It'll show the URLs that are being requested from the client. And I've added some additional logging here for this demo. Each time Origami is reading from the file system, we'll see another entry in the log. So here it's reading page.ori, and then below it it's reading about.md. So that's, we asked for about.html, and Origami is reading these files. This one in the middle is a built-in function, so there's no work that it has to do. And then that about.html page is sent to the client, and the browser will then parse it and interpret it, and that will cause it to realize that it needs some other resources. In this case, it wants to get a style sheet, and that style sheet, when it gets that, will trigger the downloading of some fonts. Now, this little about page is trivial. This is just for demo purposes, so there's almost no content here. But even still, there's, with the fonts, we've got 300K of data being transferred from the server to the client side. That's all happening on the same machine in this case, but it still does cost something to send the data over that that connection. And then there's some work that's required. So here, again, this is a tiny little page. It's just a tenth of a second, but there's a little bit of work going on. So that's to do an initial load of this page. Each of these resources produced a particular status code that is of interest to this discussion. The status code will normally be 200, which means OK, which is to say that we asked the server for something, and the server said, yeah, I've got that, here it is. Along with that, because it's relevant, let's take a look at some of the details going on. This is the response that the server sent for that web page. And along with that, the server also did a little calculation, and it calculated something called a hash. And in this context, it's called an E tag. This is essentially a big hexadecimal number that's the result of crunching all the text in this response and summarizing that with this string of hexadecimal digits. This is effectively like an ID or a characterization of this content. So as long as this content is exactly the same, this characterization, this hash, will also stay the same. Okay, so now that's when we asked for the page the first time. Let's look at both the server and the client when we asked for the page a second time. So the second time we asked for this page, in the logs, we see that the server was asked for about.html, but we don't see any file reads. That's because Origami's loaded, the server's loaded those files into memory. And it's also, beyond keeping those files in memory, it also has the result in memory, the about.html result. So it can send that back to the server, back to the client immediately. And in this case, it takes an additional step. The server, when the client asks the server for about.html, it includes sending in the request the hex hash of the previous about page. And the server says, that hex hash that you've got, that is the latest content. And so instead of sending the content again, it looks like it's here, but really what happened is the server sent a special status code 304, which means not modified, nothing changed. And when the server sends this to the client, it says, hey, nothing changed, use the HTML you've already got. So that message to the client is tiny, in here 0.2K, and that's true for all of these, including those fonts. So now what had previously been a page, again, a tiny page, but it was 300K to load it. Now it's less than 1K, and the work required was also smaller because the server didn't have to calculate any of those responses. Again, it could just return what it had returned the first time. Okay, so that's what happens when we ask for something a second time. Now, Origami's being smart. This page, whenever we ask for about.html, it's going to keep serving up the same response each time, as long as these files are staying the same. But if those change, that will Origami, the server, will notice that that's happened, will see the file change, and will clear out from the cache. It's the cached value of that file and anything that depended on it, like this about page. So let's see that. If we go to this about page and we make a little edit here, if we refresh this, we see the new content. On the server side, we see that the server was asked for about.html and it reread about.md from the file system because that file had changed. When it sent the request, the response to the client, it calculated a new hash and sent the new response and sent that to the clients as a 200 response saying, hey, here's new content. The browser loaded that content, parsed it, and realized it needed this resource styles.css. It asked the server for that, and the server said, yeah, that one didn't change. Use what you've got, and it did the same thing for the fonts. So that's what happens when we make an edit in a page like about.md. We can also make a page, an edit to the template. So this is the little JavaScript template literal that defines the base page template for this little project. And here's, we've got a definition of our header. Let's make a little change there. Now, if on the client side we ask for a new page, we'll see that the server needed to reread page.ori because that file changed. It didn't need to read about.md because that didn't change. This content was the same. This content had changed, so it reread that. It calculated a new about page and then sent that. Again, this time with status 200. If we refresh, we'll see that now it's status 304. A note about fonts. I'm using Vivaldi based on the Chromium browser, and Chromium has all sorts of special handling for how fonts work. So you may see differences in the status for that. Okay, so that's what happens if we're dealing with a single page like this about page. Let's look at this site's homepage. So here is the homepage. It shows all the posts in the blog. Right now they're tiny little sample posts. And the way this page is defined is with this formula here. So it says index.html. When someone asks for it, evaluate this expression. That's going to take the data for the different posts that's defined in a separate .ori file and pass that to this all posts template, which is going to add a header and a footer and some other things. And then it also has this line in here, this call to the origami tree.map function. That's going to take each of the posts and apply a template to them. That template creates a little fragment, which is going to be this little chunk of HTML we see here. And we'll see one of those chunks for each of the posts in this markdown folder. Now, if we look at the server logs, while that index page was being served, we see that it loaded the template, it loaded the data. It did something interesting here for the markdown folder. It needed to get the keys or the names of the files in that folder in order to be able to fulfill this tree.map request. This basically says you're going to need to enumerate all of the posts, and the way that Origami does that is by getting all of the file names, all of the keys of this folder, and then it's going to iterate over those. So it's going to read the first post here, the second post, and then turn each of those into HTML and serve that up. Each of those files is kept in memory and can be edited. So let's come here to this first post, which says hello world. If we change that, then when we refresh, we see on the server that when it was asked to serve the root of the site, it needed to reread that specific file. The rest of the files it could read out of memory, and then construct the home page and send that to the client. We see that the client gets a 200. There's new content. If we refresh again, now we see that we're getting this 304 not modified response because nothing changed on the server. And that means that we're free to edit any of the files in this folder, and those changes will be reflected on the client. And because Origami is tracking the set of files in this folder, if we add or remove files to the folder, those will have an effect as well. So if I refresh now, this third post comes in. That was this one that we just added. And in fact, if we look at the server logs, we'll see Origami realized that it needed to once again list out all the keys, the file names in that folder. And then when it read the first and second post to turn them into HTML, it could use what it already had in memory. For the third one here, it needed to read that file from disk in order to be able to generate this page. So that's a way in which Origami is tuned to work with hierarchical tree-like structures like the folders and the file system. It's not just tracking the individual files, it's also tracking the set of files in a folder and responding to changes in that set. So by tracking what depends on what, Origami can be very efficient. And that includes, second, third order dependencies as well. So for example, this about page and this index page both turn out to depend on page.ori. And if we look at that, that depends on a file here called siteinfo.yaml. If we make an edit in this particular file turns out to be referenced indirectly by every page on the site in order to be able to populate things like the site title. So if we change that, then if we refresh this page, we'll see that it needed to recalculate this page in order to incorporate the new title. And if we go to the About page, we'll see that we got a new response for that as well because it needed to incorporate the new title into this About page. So again, I think the simplest way to think about your site running locally in Origami is to think about it as if you were working with a spreadsheet that was based on files and folders, that as you edit the files and folders in the file system, Origami is going to figure out exactly what needs to be recalculated the next time it's asked for. I do want to make a special note about working with JavaScript. So one of these files here, data.ori, turns out to reference a JavaScript file. So a great feature in Origami is that you can build your site in Origami's dialect of JavaScript or in JavaScript, regular JavaScript itself, or a mix. So to demonstrate that interop, this Origami blog start project has a little JavaScript file that parses date out of text. Now, if we save this file, I'm going to just go and save it again. We'll see down here in the server that the server noticed that the file changed and that it was a JavaScript file specifically that it changed. The same thing would hold true for a TypeScript file. In that case, Origami can't use its smarter caching behavior because JavaScript files are a special kind of thing. In JavaScript, a JavaScript module like this can do anything. It can completely modify the global state of the running program, which means that if you have a project that loads 10 different JavaScript files, if you edit just one of them, there's no way for the server to isolate the effects of that file and to sort of undo those and reload just that file in order to pick up its changes. The only way that you can pick up those changes is to start over, to basically restart the server, reload the entire JavaScript world from scratch, and then let the JavaScript code do its thing. So that's what Origami does. If you edit a JavaScript file, that's not going to have caching effects, and it'll just restart the server, and that turns out also refresh or clears out the cache. So if we come here and we load this page, we'll see that on the server side, Origami needed to read all those files from the disk again, and these are all fresh responses because Origami had to calculate all that from scratch. At this point, if we refresh, then we'll see that we're getting the cache responses. So that's a special case for working with JavaScript. Beyond that, Origami can be very smart and efficient. Mostly that's going to affect your speed of local development when you're going back and forth between looking at something in the browser and editing it in a code editor. It also does speed up build times. When you're building a site, you know, the Origami build process is going to have to create all of these. It's going to evaluate everything in your site. So in that case, this equals definition isn't going to make that big of a difference because everything's going to have to be calculated. That said, this caching behavior does speed up builds by a modest amount. And that's because you can have things like multiple formulas here, for example, are referencing this data.ori file. That file will just be read and parsed and evaluated just once, even though it's being used a number of times. So this caching system does come into play in builds as well. Overall, I think this is an interesting feature of Origami. The integrated caching system lets you concisely define all the resources your site needs, and then as you're developing, it's only going to do the work required to create the requested resources, the things you're actively working on. And then that same definition can be used to create a build. And again, that's going to be done as efficiently as possible. I hope this video was informative. If you have more questions about how caching works, you can take a look at the documentation or ask your questions in the Origami chat room.